To navigate the Internet smoothly, our devices rely on a variety of networking protocols. These protocols govern how data is sent, received, and interpreted across the web. From ensuring secure connections to facilitating file transfers, each protocol has a specific role. Let's explore these essential protocols one by one. Here are the top 15 networking protocols we'll be covering today. HTTP, HyperText Transfer Protocol. HTTPS, HyperText Transfer Protocol Secure. FTP, File Transfer Protocol. SMTP, Simple Mail Transfer Protocol. IMAP, Internet Message Access Protocol. POP3, Post Office Protocol 3. DNS, Domain Name System. DHCP, Dynamic Host Configuration Protocol. SSH, Secure Shell. NAT, Network Address Translation. TELNET, Terminal Network. TCP, Transmission Control Protocol. IP Internet Protocol. UDP, User Datagram Protocol. ICMP, Internet Control Message Protocol. Let's dive into each of these protocols to understand how they contribute to the seamless functioning of the Internet. First up, we have HTTP or Hypertext Transfer Protocol. HTTP is the foundation of data communication for the World Wide Web. It defines how messages are formatted and transmitted, and how web servers and browsers should respond to various commands. Essentially, HTTP is the protocol that allows you to view websites by requesting web pages and sending information back and forth between your browser and the server. Whenever you type a URL into your browser sends an HTTP request to the server hosting the website. The server then responds with the requested web page, which your browser displays. HTTP operates over TCP port 80 and is a stateless protocol, meaning each request from a client to server is treated as an independent transaction. Now let's talk about HTTPS, which stands for Hypertext Transfer Protocol Secure. HTTPS is the secure version of HTTP, using SSL/TLS, Secure Sockets Layer/Transport Layer Security, to encrypt data exchanged between your browser and the server. This encryption ensures that any data transmitted, such as login credentials or credit card information, is secure and cannot be intercepted by malicious actors. When you log into your online bank account or make a purchase online, HTTPS ensures that your personal information is protected. It operates over TCP port 443 and has become the standard for secure communication on the web. Next, we have FTP or File Transfer Protocol. FTP is used to transfer files between computers over a network. It supports both uploading files from your local device to a server and downloading files from a server to your local device. FTP operates over ports 21 for control commands and 20 for data transfer. Web developers frequently use FTP to upload website files to their web servers. It's a reliable and straightforward way to manage large amounts of data. However, it's important to note that standard FTP is not secure, as it transmits data in plaintext, so secure versions like FTPS, FTP Secure, or SFTP SSH File Transfer Protocol are often used instead. Moving on to SMTP Simple Mail Transfer Protocol. SMTP is the protocol used for sending emails across networks. When you send an email, your email client communicates with your email server using SMTP to transmit your message to the recipient's mail server. SMTP operates over TCP port 25. SMTP is designed for simple, efficient transmission of text-based messages. While SMTP is great for sending emails, it doesn't handle receiving or storing them. That's where protocols like IMAP and POP3 come in, which we'll discuss next. Now let's discuss IMAP, or Internet Message Access Protocol. IMAP allows you to access your emails stored on a server from multiple devices, such as your smartphone, tablet, and computer. Unlike POP3, which we'll talk about shortly, IMAP keeps your emails on the server, allowing for synchronization across all your devices. IMAP operates over TCP ports 143, unencrypted, and 993, encrypted. With IMAP, you can read, organize, and delete your emails on one device, and the changes will be reflected on all your other devices. This makes it ideal for users who need to access their email from multiple locations. We also have POP3, which stands for Post Office Protocol 3. POP3 is used to retrieve emails from a server to a local device. Typically, when you use POP3, your email client downloads all the emails from the server and often deletes them from the server afterward. This can be useful if you prefer to store your emails locally and don't need to access them from multiple devices. POP3 operates over TCP ports 110, unencrypted, and 995, encrypted. However, if you need to access your emails on multiple devices, IMAP is generally a better choice. POP3 can be configured to leave copies of emails on the server, but this can sometimes lead to complications with synchronization. Let's talk about DNS or Domain Name System. DNS is essentially the phonebook of the Internet. It translates human-readable domain names like www.google.com into IP addresses that computers use to identify each other on the network. DNS operates over UDP port 53. When you type a web address into your browser, DNS servers are queried to resolve the domain name into an IP address. This process allows your browser to find and connect to the correct web server to retrieve the desired web page. Without DNS, we would have to remember complex numerical IP addresses for every website we visit. Next up is DHCP, or Dynamic Host Configuration Protocol. DHCP simplifies network management by automatically assigning IP addresses to devices on a network. It operates over UDP ports 67, server, and 68, client. When you connect a device to a network, such as your laptop to a Wi-Fi network, DHCP assigns it an IP address from a predefined range. This dynamic assignment ensures that each device has a unique address and can communicate on the network without the need for manual configuration. Next, we have NAT, or Network Address Translation. NAT allows multiple devices on a local network to share a single public IP address for accessing external networks. It modifies the network address information in the IP header of packets while they are in transit, which enhances security and conserves IP addresses. With NAT, your home router translates private IP addresses of your devices to a single public IP address. This way, multiple devices can access the Internet simultaneously, while keeping your internal network structure hidden from the outside world. NAT also adds a layer of security by masking the internal IP addresses from external networks. Then there's SSH, or Secure Shell. SSH is a secure protocol for remote access and command execution, encrypting all data exchanged between the client and server. It operates over TCP port 22 and is widely used for managing servers remotely. Using SSH, you can securely log into a remote server to execute commands, transfer files, and manage configurations as if you were physically present. SSH's encryption ensures that your login credentials and any data transferred during the session are protected from eavesdropping. We also have TELNET, which is similar to SSH but less secure. TELNET provides remote access to computers and allows you to execute commands as if you were physically present. However, TELNET transmits data in plaintext, which means it's not encrypted and can be easily intercepted by malicious actors. TELNET operates over TCP port 23. Because of its lack of security, TELNET has largely been replaced by SSH for secure remote communications. TELNET is still used in some controlled environments where security is not a concern, but for most purposes, SSH is the preferred choice. Next, let's discuss TCP, or Transmission Control Protocol. TCP is one of the main protocols in the Internet Protocol Suite, ensuring reliable, ordered, and error-checked delivery of data between applications. It establishes a connection between sender and receiver before data is transmitted, making sure that all packets arrive intact and in the correct order. Whenever you stream a video, download a file, or send an email, TCP is at work, ensuring that the data is delivered correctly. TCP handles packet retransmission in case of errors and maintains data integrity, which is crucial for applications where accuracy is more important than speed. Now we have IP, or Internet Protocol. IP is responsible for addressing and routing packets of data, so they can travel across networks and reach the correct destination. IP works in conjunction with TCP and UDP to ensure data is transmitted efficiently across the Internet. It's like the postal service of the Internet, assigning addresses to packets and determining the best route for them to travel from the source to the destination. IP is essential for navigating the complex web of interconnected networks that make up the Internet. Let's not forget UDP, or User Datagram Protocol. UDP is a lightweight, connectionless protocol used for fast, low-latency transmissions. Unlike TCP, UDP does not establish a connection before sending data, and does not guarantee delivery, making it faster but less reliable. UDP is ideal for applications where speed is critical, such as live streaming, online gaming, and voice-over IP VoIP. While it doesn't ensure data integrity, its low overhead and quick transmission make it perfect for real-time applications where some data loss is acceptable. We also have ICMP, or Internet Control Message Protocol. ICMP is used for network diagnostics and error reporting. It helps identify network issues by sending error messages and operational information about network conditions. One common use of ICMP is the ping command, which tests the reachability of a host on an IP network. By sending ICMP echo request packets and waiting for echo replies, ping can determine if a server is reachable and measure the round-trip time for messages sent to the destination. And there you have it, a comprehensive overview of some of the key networking protocols that keep our digital world running smoothly. If you found this video helpful, be sure to give it a thumbs up, subscribe to our channel, and hit the bell icon for more tech insights. Thanks for watching, and we'll see you in the next video.